go ahead and start the stream so if people were waiting for it, they don't think we forgot about class. What are we doing tonight? Lesson 1, right? Or Unit 1, we just talked about it. Okay. I got a little bit of feedback on my sign up for Math AS video, and one of the things I was told is I should smile more because I guess I was too serious in that video. So usually in class I smile, right? But when I'm making a video, I forget to. Yes.
I was doing the homework, and there was a question that I couldn't get.
Excellent. I love it. So let me get into Math AS. Was it from the online homework, or was it in? Okay, so let's go ahead and open up lesson 1. So there's this online that's an online quiz, online homework. You were in Unit 2? Well, that's why. You're way ahead of us. Heck, I don't even understand lesson 2 yet. Okay. Okay. Oh, no, this is good. Well, let's just take a look. Algebraic expressions. Sure. But do you have the question number? Do you remember which number it was?
Somewhere in the middle, I was almost done with it.
Something like this. Notice lesson 2 is less than lesson 1, so this is that's good to look ahead. Cost, revenue, profit.
No, I don't think it was that far yet.
17.
The equation is combining the like terms.
Okay. So what did they give you?
4, and in parentheses 9m minus 18, plus 6 over 3. No,
The whole thing's over 3.
And then all that plus 7m minus 10.
Minus 10? Yeah, that's the one I put on the test. So no, this is the definite one. As a little bit beyond what we're going to do today, but we'll just do a real quick refresher.
I was trying all kinds of different ways, but then
Okay.
you gave me the correct answer, and I wasn't sure how.
Okay, so we'll just talk through this, and then when we come back, what we'll be doing today is a little bit easier than this, not as complicated. But order of operations, right? So we've got a top of a fraction here, we've got a bottom, so we look for grouping, and we got stuff over here. And, oops, it's all fuzzy, let's see. It's supposed to autofocus, and the pen wasn't very dark, so let's see if this one. Okay, so we'll distribute, and again, we have a whole lesson on that, so if this is familiar to you, great. If not, don't worry about it. We go all over that in lesson 2. Again, the kind of the approach I take is that you all have a bit of a road built, some more than others, but we got some potholes, and we fill in those potholes. But some of you maybe need more construction on certain things. So what's 4 times 9? So that's 36m. 4 times 18. It's negative. 4 times 8 is 32. Carry the 3. 4 times 1 is 4 plus 3 is 7. 72. Good. And then so that takes care of the parentheses part. There's a plus 6 all over 3. Plus 7m minus 10. These can get added together, but this is negative and this is positive. So it looks like that's going to give us what? 66. So you subtract them, and it's going to be negative. So the next step is 36m minus 66 over 3. And this is the part that probably where you went. This is usually where people go wrong. What do we do with this 3 now? Yeah.
I didn't reduce the 66, I just reduced it to.
Okay. So this is really just, it's the top part, think of it as a parentheses. What we're going to do is we're distributing the 3, but we're distributing division. So just like we distributed the 4 to both of these terms, we're going to distribute the 3 to both of these terms. So I'm going to come back this way. This breaks down into 36m divided by 3 minus 66 divided by 3. And again, that's typically the area where people will mess up. And we'll do several of these together. So again, if it's just kind of feels like it's out of left field, it sort of is, we'll do this in lesson 2. And then we've still got this plus 7m minus 10. 36 divided by 3 is 12. 66 divided by 3, 22. Okay. Yeah, so we have to do that, and that's where the error is. Now we can combine these. Negative 22 and negative 10 is going to be negative 32. And we can combine these two, 12 and 7, 19. That's probably the answer it gave you, right? And that's, yeah. So it was just a simple, take the 3 and think of it just as distributing it to both of those. Okay. And that's kind of what we're going to focus on today is we do this story of X thing where basically we're going to look at the variables and we're going to describe what's happening around them, okay, as the basic building block to get us into being able to do this. So one of the things you have to learn about today is to slow down, and we are not solving anything. You're going to want to solve a problem. They'll have some tickets, adult ticket price and children ticket price, and you want to solve how much it all costs. That's not what we're doing today. We're setting it up. We don't get to solve that problem until lesson 3 or unit 3. So this is the hardest part of it, is we really are going methodically slow just through what is a variable and what's the expression. And your mind is going to skip to, because we're natural problem solvers, you actually want to try to solve the problem or answer the questions. Most of the answers to our questions, in fact, actually all of them, they're going to be expressions. They're going to still have a variable in it, and it feels like you're not done. But for this lesson, you're done. But it builds us up so that by time we get to, and even this one, it doesn't really feel like we're done because we didn't end up with a number. We won't start ending up with numbers until unit 3, because that's where we get equations and we can start solving things. But even in lesson 2, it's very unsatisfying because we get done and we still got a math expression here, and it still feels like we need to do some more. But in these 2 lessons, it's not. So we're just building foundations, and what they will do is they will prepare us for lessons 3 and 4, where we will actually start solving some problems in the world. Okay, so let's go ahead and take that down. But that's what I'd like you to see, is that it's good to bring questions to class. That's what we'll start with and end with if we need to. We go till 7:15 officially for class. We'll try to start more on time. In the future, I'll probably be able to get here. I need to get here at least 10 minutes early to start setting up. But we'll go maybe till like 6:30 as far as the formal part of class. And then whatever happens after the formal part of class, we'll stop the stream because that's done. There'll be time for you to work on problems, log in if you've got a laptop or whatever you need to do, or head on home if you need to do that, and then the rest of the time. So this class has about an hour's worth of tutoring built into it. And sometimes, some weeks it might be a little bit more, but that's what it's for. And if you understand things are moving along and don't need it, that's your choice. Or if you've been working all day and this is about as much as you can take and you need to go take a break before you can actually start working on the stuff, that's fine too. But we'll shoot for, by 6:30-ish, we'll have discussed everything we sort of need to discuss for a good, and you'll be ready to get started. Okay. So let's go here in the Math AS. Any general questions about Math AS or Canvas or yet? Where do you go in Canvas if you want to see live stream notes or you want to verify attendance? Modules, good. We go to modules, so that's good. So I'll get to Canvas, see that thing that says modules, click on that. That's pretty much where the course communication stuff happens. So that's where that'll be. If it's course content stuff, it'll be in Math AS. So the textbook, online homeworks, videos, those things are there. Of course, Canvas has the class videos, but basically for working on Unit 1, all you have to do is go to Unit 1. Everything you need for Unit 1 is going to be in here. Okay, so we've got a student workbook. You could pull that up, print it off, or if you've got it from the textbooks, you could have already purchased this if you wanted to. There's the media lessons, where this one has 14 videos you could go through, and that's the way the online classes work. They just watch these videos, and that's their instruction. Some teachers, even though they're face-to-face, they require that you do these and you fill out the pages, and some collect them. I don't. I encourage you, if it's helpful for you, to do that. But also, if there's parts that you already understand, you can skip over it. Okay. So, but these are here, these videos for instruction, walks you through the student workbook. And there's the online homework, and that's what we're going to be working towards doing. We may look at a few of these before the end of the night. And there's the online quiz. What could we do with the online quiz? You could do that instead of the homework. You might choose, it's only 15 questions, you might choose to do it first. It has basically all the types of questions that you need to know about. The homework does too, but it might have 2 or 3 of the same. That's why there was like 30 or so questions, or 40, whatever there was in the homework. The quiz is going to take you through quicker. And if you go through and you understand it, great. And if you don't, that's great too, because it does tell you maybe where you need to pinpoint, where you need to study. And again, each of you different, but if you can understand what you need, and go ahead and do that. So this is here. Some of you may use this as a final thing. After you've gone through the homework, try this out to see if you really understand it. Do you have to do the quiz? No. It doesn't get into the grade book anyway. So it's just there for you. And you could take it again and again if you want. You can take it at the beginning and at the end. Again, it's there for you. Okay, good. So that's the quiz. So those are our resources we have. And there's even, well, I have access to something called an online test. I don't know how I hide it, because in the past, I'll have people use the quiz, but they rarely like to use the test. It's even shorter. I think it's timed or something, and but if you like to take tests just for practicing, just let me know. I can unhide them, but otherwise I'll leave them hidden. Okay. So where should we start? How about the student workbook? And then we get to, in the student workbook, it actually has 2 problems. Notice there's answers to practice problems and answers to you try. So if you use this, the workbook, you will have access to the answers as well. Someone told me that actually not all the answers to the you tries are there. I've never really looked that closely. I know some of them are there. I thought all of them were supposed to be there, but if they're not, those are good ones to ask about in class. What's a you try? Yeah, you try it. There's no video for it. The other ones have a video, so as you go through this, you'll see example 1, there's a little computer. That means there's a media lesson. There's a video that walks you through this. Same thing with 2. There's a video that takes this question and they walk you through it. Okay, so it's right in the videos, same as that, until you get to something called a you try. There's no video for this. It's for you to try. But that's where we have, at least some of them, they have the answers to these. So after you've tried them a bit, you understand. You can see whether you got them right or not. Maybe it'll help you as you go through things. Okay. So then we get into the story of X and so forth. So I'm going to take just a basic example from this first question, and I want to take a look at how we sort of can use a variable and use numbers in places of variables to understand what's going on. Okay, so first of all, what this is trying to understand how two numbers are being combined with operations. What are the operations we have to work with? We have 4 of them. What's that? Oh, what are the 4 operations we have to work with? What's that? I think you said it. Very good. You got division, multiplication, addition, and subtraction. Those are the ones we'll pretty much be working with. We do have exponents too that we could use. Try to get a good marker. But those are the ones we have to use. So those 4. And so as we go through, when we read a story problem, we're trying to figure out, are we adding, subtracting, multiplying, or dividing? Okay. So in this first, and then we'll see how we could do it. Okay, so example 1, we're given a statement, Juan is 6 inches taller than Nico. Let n represent Nico's height in inches. Write an algebraic expression to represent Juan's height. So what do we know about Juan? 6 inches taller. Better switch over here. Okay, so Juan, he's taller than Nico. Maybe not that much taller, but we'll just emphasize. So Nico is smaller, Juan is taller. Okay, and we know by 6 inches, so the difference six-inch difference. So let n represent Nico's height. So what we do is Nico's n, if I know his height, and this is where I'm going to help you a little bit with what I do. This is kind of how the Chinese did. They didn't really do algebra, but let's just say, what if I told you that Nico was 60 inches tall? What would I do to that 60 inches to get Juan's height? At 6. Okay. But I made the 60 up, so that must be what n is. So what do? I take n plus 6. But how many of you were thinking, what do I do to n to do it? You know, it's sometimes hard to start with that. But if I give you a number, he's 60, what do I do? 60, well, you just add 6 to it. Sometimes it's when we work with numbers, our minds are hardwired to just kind of deal with it, and they understand, okay, yeah, if the other guy's taller, I got to add 6 inches, and then that means that Juan would be 66. So if I give you numbers, it's sometimes easier to work with. So one of the tricks I've used is I go ahead, and same thing for me, it works this way. I go ahead with numbers, and I say, wait, this is the part I made up. That's really n, and this is what I want, n plus 6. So Juan's height is Nico's height plus 6 inches. Okay. But sometimes, we draw a little picture or something, because if we just read the English, the way our brains translate, sometimes we think, oh, Juan is taller, so we think we need to add the 6 to Juan's height, because it's connected to Juan. So the 6 is connected to Juan in the English sentence, so it's very natural to say it's J plus 6 will give it to us. But when we think, wait, Juan's taller than Nico, okay, whatever Nico is, I have to add to his height to make them equal. Okay. The next question is the same, only it's in reverse order. If I know Juan's height, how do I get Nico's height? Exactly, very good. And this is a lot what we do with algebra. If I know one way, usually going the opposite, trying to find the other thing, is just a reverse. So addition becomes subtraction. Or subtraction becomes addition. Multiplication becomes division. So those are the two that are kind of partners. So, right, so I see this, And so the second part, so this was example 1. So for example 2, they're wanting to say Juan is still 6 inches taller than Nico. That hasn't changed. But now they want J to represent Juan's height, and we want to figure out how would we figure out Nico's height. So if we know J, let's say it was 70 inches, how do we find out Nico? If he's taller, we got to subtract to get smaller. Oh, that's what we do. This is the number I made up, and you could make up anything. There's nothing sacred about the 70. Make anything you want. That's what I made up, so that's where the J goes. So this expression should be J minus 6. Okay, just like that. And that's where we're stopped. That's all we're doing today. We're not trying to solve or do, because we don't have anything. But what is going to help us is when we do get into 3, it'll help us set up problems, and then we'll be able to solve them. So far, so good? Okay. And if you have questions, please ask them as we go, because that's what the people, and by the way, welcome to everyone who's watching live or recorded. That's what the people who aren't in class, but they're watching live, they're hoping that you ask the question that they're thinking in their mind, because I bet you they have questions, but they have no voice to come through, because I haven't figured that part out. They can't get messages to me, so they're kind of trying to get through you, whatever questions you have. They want you to ask them, because it's probably the questions they have. Sometimes you don't even know what question to ask, and I love to have a student that says, I got questions, but I don't even know where to start. I just don't understand this. And so then I'd start on 1, 2, 3, and she goes, oh yeah, that's the question I had. But she didn't know what it was. So we'll work with it. And again, if you have questions, even if you don't know what that question is, try to get something out, and we'll figure it out together. Okay. So far, so good? Okay. And she'd say, no, not good. I said, okay, well, we'll try to make it good by the end of the night. Okay. And again, a lot of examples to try on those, so we'll get to this part, because this is a part where it's a little bit different. And I'll be honest with you, when I first saw this was revised a few years ago, and I thought, this is real corny, this story of X thing. And I went through a workshop, and I had to sit for hours, and we went through this, and they tried to explain why this particular approach was so good, and why it was so important to do it in a particular way. Yes, sir?
I'm sorry, can you go back to that other one again? I have a question.
Sure, good. Which?
That didn't really make sense.
Up here?
Yeah, see, to me, I don't know if I'm reading it wrong or something. To me, it seems like it would still be 6 plus J for the number 2.
Mm-hmm.
Since Juan is 6 inches taller than Nico, same thing with the first one, Juan is 6 inches taller than Nico. All you're doing is just changing the letter, it seems like. So you still would technically, like number 2, to me it seems like you're still adding, you would still add 6 inches.
Okay, so let's take a look. This is where it's also the nice part. If we put in a number, again, and we're making it up, we can check if it's reasonable. Because if we just put a letter and then put plus 6 or minus 6, we might move on and say, sir, that sounds fine. But if we put a number, we can get an answer, and then we can see if it's reasonable. Okay. So for number 2, Juan is 6 inches taller than Nico. Let J represent Juan's height in inches, right? So J is for Juan's height. If we add 6 inches to Juan's height, well, let's get a number for Juan. Let's say it's 70 inches. If we add 6 to the 70 inches, what do we get that Nico is? Nico's 76. That means Nico is taller than Juan. Oops, there's something. Does that make sense?
Okay, yeah.
And I get what you're doing is you're seeing that first sentence, but where the change is in the second sentence that J represent Juan's. So it's not just a substitution of letter, but it's also a change of which person is being referred to. And that's the other thing with algebra, and I thank you for going back, because those are the types of things we need to uncover, is when we just do with letters, they don't really have that much meaning to us. They are just a different letter. But then when we think of it, that stands for something else, and what we're doing is we're changing our perspective of which one we're referring to. So while on an abstract level this seems fine and it seems to fit the first part, Juan is 6 inches taller, and I'll be honest with you, this is the way I would have seen it, yeah. But when I put a number in, oops, Nico is, or Nico, he's 76 inches, and that's taller than this, and he's supposed to actually be, Nico is supposed to be the shorter one. So a lot of times when you do this, you'll be able to see those relationships, and you'll say, okay, what if I subtracted 70 minus 6 is 64. Okay, now Nico is shorter than Juan, and there's a difference of 6 inches between them.
That's how you can get that difference.
Yes, yes.
I don't mean to go like too far off topic.
Okay.
I was just looking at the AS. I was just a little confused. I know you said that homework is the only thing that counts in the grade book. There's something called like a warm up and a media lesson. Just completely disregard that.
Sure. Well, it's yeah, it may be in there. Those are just for you to get comfortable with Math AS, so you're welcome to try them out. But yeah, unless you say, well, hey, could I have a little bit of extra credit for it? I'll say sure. So if you do some extra work and you've thought, oh shoot, I did all this work and I really didn't have to, don't worry, it's recorded. We'll get them. We'll make stuff count for you, but we won't make stuff count against you. So we'll always I'm always more happy to throw in some extra point because you did some extra work. And if you miss something, I would rather overlook it than to try to take something away from you. Just, it works better that way. Okay, good question. Okay, awesome. And so part of this is just learning to work with variable. What is a variable?
Represented by a letter symbol.
What's represented by?
Like X, Y.
Okay, so that. Good. The letters.
Can you represent it in parentheses?
Okay, we can do that too. And what did you add to the? Okay, so we use them in expressions. They're letters, and they stand for numbers if we put all of that together. And that's really what, it's a placeholder. It's because we don't know them yet, and that's why we have them in expressions. It's a value we don't know. And we will eventually be able to solve for it, but not till, not till lesson 3. But yes, it's what we want to know. We really want to know, how tall is Juan? We want to know, how tall is Nico? All we know right now is Juan is 6 inches taller, but are they this tall or are they that tall, or but we don't have enough information for that kind of stuff. But the variable could be represented just by an empty box, but we oftentimes do it. It is a placeholder for a number we don't know. And there are two kinds of variables. One variable is a number that's sort of fixed, but we don't know. So like Juan, he is a certain height. It's not changing from minute to minute, unless he's on some human growth hormone or something. But he's got a height, it's fixed. We just don't know it, okay? There's another type of variable which we'll get to more later on, and that's a variable, it's a value that can actually change. A variable speed saw or drill, it can vary. It can be fast or it can be slow, depending upon how hard we pull on it. We drive our cars, our variable speed vehicles. We put the pedal down, we go faster. We pull back and hopefully we slow down. So variable speed. So variable can have two sort of aspects. It could just be an unknown that has a fixed value. It's not really variable, but it's an unknown type thing. And then there's other variables which will actually change, like the number of hours I work in a week, maybe. Sometimes I work 40, sometimes I work 30, sometimes I work 80. Okay, so that's a variable, a real variable, okay? But then there's other variables of how much did I work last week. It's a certain number. It's just maybe I don't know it, or you don't know it, okay? So there's those type of things. But all those things you said are absolutely correct. And what I want you to see is in math, oftentimes, let me switch over here. I got one story for you. It's a short story, but have you ever heard this one before? These three men are going through the jungle, and they've got blindfolds on, so they can't see. It's kind of dangerous to go through the jungle, I know, with blindfolds. They come upon something that blocks their path. And one of them, and they got blindfolds, so they can't really see. One of them saying, oh, it's a big wall. It's kind of a hairy wall in our way. Another one's kind of, because he's kind of tired, so he started crawling. You know, he just didn't want to walk anymore. He says, no, it's not a wall. It's a tree. I can feel its trunk down here. It's a tree. And then the other one's over here says, oh, guys, no, it's a snake. And they're all three right. What's in their path? What could be a snake on one end, a tree at the other, and a wall in the middle? Well, put yourself in Asia or Africa, and you might run across an elephant who's got a trunk that might, if you're feeling that trunk, it might seem like a snake. If you're feeling the legs because you're crawling along, it might feel like it's a tree. And if you run into the body, it might feel like it's a wall. But it is all three. And what does this story have to do with math? Nothing at all. No, it has something to do. Math is oftentimes like that. We see a little bit and we think that this is what it's like. But then we go to work the next problem and say, no, it's nothing like that. But it's not true. It is like what we saw over here, but we're seeing a different part of the application. And sometimes a variable is actually more than we think it is. We get using it, and yes, a variable can be just a holder for something we don't know. But you're going to see quickly as we get later in the class, the variable will actually be variable. It's a number that can change and will change and can take on many different values. Okay? But it's as we go through math, that's one of the problems is we'll focus on and we'll think, I understand this now, I got a snake. And because we've studied the part of the animal that feels like a snake, but the part of the animal that's like a wall is still there, and we have to put the two together. It's not a snake and it's not a wall, but when we put it together, oh, it's an elephant. Okay. So that's part of what we're doing through this, and we're going through this world of mathematics all it's like we have blindfolds on because it's very abstract stuff. And we're trying to explain and understand this stuff, but it's like with the blindfold on. We don't see the big picture. We don't see the whole picture because sometimes we just couldn't handle the whole picture at once. Okay? But we'll see the little pieces, and hopefully we can put it all together, and we'll see when things change. Okay. How are we doing? Just got 30 minutes left. So now we're going to take a look at this. And if you want to have a piece of paper out to just kind of try and follow along, these are all in the video lessons, so you can watch these separately. Some of you may have already watched them, and that's great. But I'm just going to walk you through why I think the story of X actually ends up being a very good activity. And again, it was one when at first blush I said, what is this stuff they're coming up with? They're making up some new math as they go, because I had never seen this when I was learning math. But I believe it's pretty powerful. So the story of X is what we want to do is we're given an expression. And we want to look at the spot, the location that's being marked here as X. That's sort of the center of the world. That's where the story starts. It always starts with X. And we want to go out from there. We want to explain what is happening to X. So if I look at X, what's the first thing that happens to X? X has 5 taken away from it. Does that make sense? X has 5 subtracted from it. So multiple ways we could say it, but it's not. But this is the thing: is in algebra, that's what we want to start with is the variable. What is happening to the variable? But because we were taught arithmetic first, a lot of times we're going to start with the number. We might say 5 is being subtracted from X, which is correct. But again, it's the story of 5, not the story of X. Who's the center of the story? X. So X has 5 subtracted from it. And then that's the end of the story. Quick story, right? And again, you could write this differently, but always start with x. So now, this is the one that's going to be a little bit harder. Oh, sorry, folks. So if you're online, these are coming from, what is this? This is the media lesson packet. So you should have that out, and we'll come back up here so you can see it being worked out. So the next part of the story, this was a, b, 5 minus x. Again, we say it 5 minus x, but when we tell this story, we want to start from the perspective of x. So how do we explain it starting with x? Beautiful. X is subtracted from 5. Good. So we see that subtraction is weird because it's got we could say subtracted or subtracted from, and those are two different things, right? We're switching the order. So order and subtraction is very important. X is subtracted from 5. Okay. And again, part of this is just getting you used to starting from the variable. Because when we go to solve things in lesson 3, all the way down the road, that's what we're going to need to think is what's happening to this variable, and then we're going to undo it. So we'll work backwards. So we need to know the story this way so that we can work backwards to solve this story. Okay. Let's take a look at C. Right, 2x. So we say 2x or 2 times x, but how do we tell the story from the perspective of x? Good. You told the story of 2, you told the story of x. Good. X is being multiplied by 2. Or you could say x is being doubled, another way. So if you want to get, some of you want to be writers or something, you get very verbose with the descriptions, or you could just be simple and say x is multiplied by 2. Good. Okay. Eventually, we're going to see that this is it's a bit contracted, but we're going to say when we get to the multi-part steps, that's where it kind of helps. And what we really want to do is we want to just focus on, with the variable, what operation is happening directly to that variable. Because when we go to solve, we're going to do the opposite. Okay. How many of you were rebellious teenagers? Your parents told you to go left and you went right. You're going to do awesome in this class, because when we get to solving, that's exactly what you got to do. I tell you to add, you're going to subtract. I tell you to multiply, you're going to divide. That's what makes for success in this class. So I know sometimes I was, but then I always felt guilty, so then I would compensate the other way. Mom was really sweet. She just had our best interest at heart. But when you're a teenager, you think you know everything, right? It just was, yeah, my parents got so much smarter as I became an adult. Actually, they didn't change. I just realized how stupid I was when I was a teenager. Okay. Okay, so far so good. So let's come back here for those who are watching. Let's watch some double step things. So here. Oh.
X is being multiplied by itself.
Very good. We could say x is multiplied by itself, or you could say x is being squared, but that's kind of maybe it's not descriptive enough. But yeah, x squared really is x times x. So I think when you say x is being multiplied by itself, you're breaking it down to what's really happening. You're saying x squared, sometimes you're not really sure, but you just remember some things. Because I'll see students that will confuse x squared with the square root of x, right? We won't be dealing with these, but I'll see that sometimes they'll interchange the words for these, and sometimes it seems like maybe they don't really understand what's going on with this. But if you think of x squared as x times itself, that's really helpful. let me get the folks here. So yeah, it really is x times x, so we write it out as x times x if you want. Story of x doubled, or x is multiplied by itself. How, you know, again, this is where we get some creativity in writing. And that's sort of, as you're going to see, the trick is we really need to have only one x. So if I do x times x, I've got some problems here, but if I do x multiplied by itself, it actually helps with solving. Although, just to let you know, we're not going to solve any x squareds. That happens in Math 121, not this class. Okay, so let's back up here. Let's go to these multiple steps, and we'll get, because actually that'll help us maybe with C. C is kind of going to be like the most obnoxious one we'll do, but we'll see that all this stuff we've done so far will help us. And incidentally, I see some of you taking notes, and this is just sort of a reminder. If you feel inclined, it's helpful if someone will share their notes with me and the class. I've got an app on my phone where I can just quickly take the pictures. It saves it as a PDF, and then I can upload it to Canvas. So then in Canvas, we've got a recording of the live stream. So you've seen kind of what's been going on in class. We've got notes from someone who was in class taking them. So we've got some written stuff. And then we've got all the stuff in Math AS. And I just like to provide live changing artifacts of what's going on in class. So if at the end of class someone can remind me, and again, just it can be different people, but if you'd be willing, it would really, I think it'd be helpful for others in the class as well.
And once those are uploaded, we can use those.
Oh yeah.
Tests and everything.
Sure. Yeah, you get a page of notes for the tests.
Yeah.
So yeah. Okay, so our first one, 2x plus 4. That's how we read it. So we're going to write it up here. Question A is 2x plus 4. How do we tell the story of x from the perspective of x? What's the first thing that happens to x? Okay, x is multiplied by 2, and if you're like me, I like to just use shorthand, but if you want to write out, you're fine. What's the next thing that happens? Added to what? To the result of 2 times x. So this gives a result. So this is, and I'll just walk you through, that's sort of the way we use the English. X is multiplied by 2. The result is added to 4, or 4 is added to the result. Result, because usually we want to still stick with what the result has 4 added to it. Okay. And it's, again, so what I want you to see is that x is multiplied by 2. That's a complete step. And then the next step is we have 4 added to it, to that result. So 2x becomes a number, and that number gets added to 4, or 4 gets added to that number. Okay, so 2 steps. That's how it goes. And then when we go to solve these things, what we'll do is we'll work this backwards. And so instead of adding 4, we will subtract 4 from the result. And then we will take the result, whatever that was, whatever we started, and then we will divide by 2 instead of multiplying by 2. So you'll see how this works out when we get there. So later on, we do a little bit of story of x, and then we decompose it, and we go backwards to solve a problem. Okay. And watch how that is different than the B part, which is 2 parentheses x plus 4. How has this changed the whole story? The parentheses.
Don't you have to do x plus 4?
You got it.
And
It's
then-
changed the order. And when we go to solve, it's going to change the order of the, yes, so x is added to, or x has 4 added to it. And yeah, the result is multiplied by 2. And, I don't care. There's multiple ways to write these, so don't, if you look at the answers and yours doesn't match exactly, if you got the spirit of it, that's good. Okay. So something along those lines. But recognizing that now this is different. All the symbols seem to be the same, but those parentheses being put there, we're going to add the 4 first, then multiply by 2. So again, when we go to solve, we're going to be coming backwards. So the first thing we're going to have to do is divide by 2 and then subtract 4. So this gets solved differently than this one. Okay, so it's not always that we subtract or add first, or so we got to watch for the whole, how is this expression constructed? And then if we understand how it's constructed, we can unconstruct it. And that's really what solving is. We take it apart. Did I give you the definition of what algebra means? What did I tell you? I told you it's from Arabic, probably, right? Algebra. Algebra. So it's an Arabic word. Because the Arabs, but see, people think that, well, the Arabs sort of invented it was their art form of it. They did get their mathematics. They went to India to study math, so they got the higher learning from India. But they made the algebra, they really made their own. There's really an Arab construction. But their word, because it got attached to a type of math, in the Old West, there was somebody in the Old West town who was called the algebraist. Can anyone guess who the algebraist in town was? You come to this, we're in Arizona, right? The Wild West. Who was the algebraist? You ever go get a haircut? The barber was actually the algebraist, because a barber had another job. And that's if you were out in the wilderness and you fell off your horse, broke your leg, they would actually bring you to the barber, because the barber was the only one who knew how to, not only knew how to cut your hair, he knew how to set your leg. And hopefully you don't have to go to that far, but when you've fallen off in the desert and a couple days later show up in town with his broken leg, what does the algebraist have to do? He has to break your leg again and then set it. And that's literally what algebra means, is to break into pieces and put back together. So the algebraist from the Old West, and I'm not making this, well, I'm not making it up. This is what my math teacher told me. I didn't verify, I didn't do a fact check on it, but I'm assuming it's right. But that's what I was told, is that there was actually, the barber was also oftentimes called the algebraist, because he was the one who would set bones. And that's a pain, and the other connection is that sometimes doing algebra is painful, isn't it? But that's the connection. Okay, so far so good? Okay. So we're taking things apart, putting them back together. That's algebra. It's a construction. So let's take a look at this monstrosity called C. And this one, we've got 5 times quantity x minus 3 all squared minus 2. And again, we read it from left to right and go through it. But what we want to do is to be able to solve this thing, we want to understand this from the perspective of x. So what's the first thing that happens to x? X has 3 taken away, x minus 3. However, yeah, x has 3 subtracted. X minus 3.
The first thing we do is parentheses first.
Exactly. First description. What happens next? We got a result. The result is raised to the second. I like it. Or it's the result is multiplied by itself, but raised to the second is kind of, it puts the emphasis on the actual operation itself. So the result is raised to second power. Something like that, or something. Exponent of 2, whatever, however you want to write it. Good. So that takes care of that. What happens next?
That result is multiplied by 5.
You got it. We got to do this before we can do that. So now we're understanding. So that result So now we got a new number. And what do we do with the last thing we do to that all? We subtract 2. So again, the result has 2 subtracted from it, or just the result subtract by 2, however, whatever makes sense. Minus 2. Good. So far, so good. So if we go to solve this thing, what do we have to do first? Close. We're going to add 2. Good. That's the rebellious one back there. She said she was rebellious, and she was.
Why are we adding 2 again? I'm a little lost.
Because we're going backwards.
Oh, we're going backwards.
Yeah, so this is like in lesson 3. If we were going to solve this one, we come backwards and we do the reverse thing. We're rebellious people. So we would add 2, and then we would divide by 5, and then we would find a square root. Again, we won't do this stuff in actuality, okay? And again, we would add 3.
That's if we're working backwards from what we're rewritten.
Yes, when we're in lesson 3, yes. So I'm always looking down the road to what we're going to be doing. So we're like playing a chess game. You want to try to play 2 or 3 steps ahead. So I want to connect you to where we're going. But for now, this is all we had to do. But the reason we're doing it is we want to be able to undo it. And to undo something, you go backwards and you do the reverse. How many of you are mechanically inclined, have worked on an engine of some sort or mechanics? Yeah, you want to tighten a screw, you go to the right, right? You want to loosen a screw, you go to the left. You want to take something apart, where do you start? The outside. You can't start in the middle of a machine, right? Or maybe you could, but usually you go this way. But when you want to put something back together, where do you start? In the center, and you work out. Because by the time you got it all back together, if you missed a part, you can't go back and put it in. Believe me, I've tried. I've rebuilt 2 engines, and I've had extra parts left over, and I go, I wonder if these are important or not. One of them, yeah, it ran for 2 weeks, and I guess it was not that important for the first 2 weeks, but after 2 weeks, the engine just went boom. And so I think I missed something, something. But that's, think about it. Is when you take something apart, you come from the outside and you work in, and then to put it back together, you go the other way. And that's all that we're doing with algebra. This is dissecting it sort of from the point of view of x out, but to solve it, we come the other direction. Okay? So it's just all these things, yes.
So, I know that, I get that, but maybe for somebody who doesn't get it, could you just put a number in X and do the problem and show it so that somebody then would see what you're talking about if you went backwards?
Certainly.
So if X
Certainly.
were 5,
Yes, and you're exactly right. This is
somebody might not still understand the whole X.
so. This is order. In fact, from arithmetic, this is what we taught you as order of operations. But in this case, it's a little specialized because we need to start in algebra. We need to start with from the position of the unknown. In arithmetic, we know everything, so it's like, yeah, we got to start here. But do we focus on the 5 or do we focus on the 3? It's kind of a toss-up. But you're right. We could put this and we could say, okay, if I start with letting you know that this is 5, what would we do? Subtract 3 from it. And then we got to square it. So we'd have 5 minus 3 is 2. 2 squared is 4. And then we got to multiply that by 5, which is 20. And then we'd subtract 2 and we'd end up with 18. So yes, this is a very good suggestion. I hadn't really thought of that.
Thinking about what you said is somebody over there might not still understand it.
Exactly. So, this is all we're really doing. If we can't understand the story of X, well, let's use a story of what we would do with the number. Because a lot of times if we plug a number in, so we locking people out now? Oh, okay. A lot of times when we start with the number, we know exactly what to do. Okay, and if you do, that's a good way to start. So yeah, 5 minus 3 is 2. We square that, there's 4. We multiply there is 20. We subtract and we get 18. And we come back and we can maybe compare to what we wrote. Well, what did we do? We took 3 away. Okay, that's the first step we did. We raised it to the second power. That gave us that. We multiplied by 5. That gave us that. And then we subtracted 2 and we got 18. Yeah. But we remember we made up the 5. We could have made up any number we wanted. But that works. And then now maybe these words make sense. Yeah, good. Very good. Okay. Tell the story of X. And then they get us to this where they tell us the story and they want us to write the expression. So let's see if we take example 4, or actually let's do a U-try. Does that sound good? Shall we do the U-try? Well, tell the story of X. And let's do the U-try part B. So we get to see this taking the story and turning it into an expression. So multiply X by 2. How do you write that? X times 2. Could be 2x, right? So we could go X times 2, or we could go 2 times X because it's commutative. And typically we'll see it as 2x. Okay, that's what 2x is it's 2 times x. So we could just write it that way. But again, if maybe you want to follow the story exactly, either way is okay. What's the next thing that happens? Step 2, plus 5. So we're adding 5, so that looks like that. And then we're going to raise it to the second power. Can we just do that? Parentheses, good. We got the result, so we have to force it. That has to be done first, and then square. Because remember, exponents are going to be pushy. They're going to take over the place because they're supposed to be done first. But we want this stuff to be done first, so we protect it with a parentheses. Say, you got power, right, but you wait your turn. These guys got to be done first. So, perfect. So now you understand how to take an expression, turn it into a story, take a story, turn it into an expression for X. And then this is where we get into plugging in and evaluating. So they will give us an expression, just like we did here, and they will give us a value, and then now we go ahead and, yeah, W is 2. Exactly. And then you actually get a value, okay, a number. Here we've got 3, and we've given 3 values, okay. And again, these are all videos. I'm going to do this one together because this one is sort of unique. And some of you will get a wrong answer, but you'll insist that it's a right answer because you did it all correctly. Okay, so I'm going to take down this stuff. And we're just about to where we need to be. So I'm going to write the expression. We're given that A is equal to -5 and B is equal to -3. Now this is one strategy, one technique that I really not only suggest you do, but if you're, especially if you have any kind of difficulties, it's probably because you said, I don't need to do it, but maybe you do. When we are plugging in values for a variable, those variables have a tight parentheses around them. So A really is kind of like got this bodysuit. B has a bodysuit. This is going to tell us the order of operations here. So before we plug these in, we're going to put the parentheses, and then we're going to rewrite it without the letters, but right underneath. So the variables have disappeared, but we know that this one is supposed to be the A, this one's supposed to be the B. And I'm going to show you, especially in this case, if we don't do this, we actually get a different answer. So what is A? -5. So we're going to plug in, switch the colors here, -5. And B is what? So we'll put in a -3 here. So this is -5 squared. (25), because it's a -5 times, it really is -5 times -5, which is a +25. Okay. Subtracting -3 times -3, +9. And then what happens next? 25 subtract 9, 16. Then we're done. We got down to one answer. Now here's the deal is, and they've changed the test. I don't know if this is particular one's on it anymore, but this is usually typically one that they'll put on the final exams and stuff. Because here's what a lot of students will do. They'll start off with a squared minus b squared. They'll put the -5, but they won't put the parentheses. They'll put the -3 here, but they won't put the parentheses. And they're not quite sure what to do with it, so they plug it in their calculator as -5 squared. And their calculator tells them what? Tells them -25. And they think that's right. And then they'll have this minus here. They'll put this one in, and it'll tell them it's -9. And everything I'm doing here is actually wrong, so don't. So then we get -25, and if they put that in their calculator, that becomes a +9. We do get 16, but we get a -16, not a +16. So these are different. What went wrong here? Why is this one wrong when the calculator said it was right? Right, it's because we need this, and the calculator needs this parentheses around it, because here's what happens. If you don't put that parentheses, the calculator sees this as do what first? Exponent. So it's going to put the exponent on a 5 and then stick a negative on it. So it's squaring 5 times 5, which is +25, and sticks a negative on it. It does the same thing over here. But in algebra, what we're expecting you to do when you plug in for a number like this is that a has this parentheses around it. So if you do this on your calculator, parentheses -5 squared, it will give you the correct answer of +25, because it takes -5 times -5. Okay, so it's just it's sort of a technicality thing, but we can kind of maybe understand why that is. But it's just every time we're going to plug into every time we're going to plug into a variable, put a nice tight parentheses around it so that it all will happen correctly. Okay. If you know what you're doing, you could write it this way, and then you know that that's supposed to be included, and you could still come up with the right answer, maybe mentally. But you got to make sure.
There's multiple ways you could do it like that without.
Yes, there always is, but one of the multiple ways is wrong. Yeah, and sometimes you're not sure which one's right, which one's wrong. But this is wrong because what is intended by this is that there's supposed to be parentheses there. Okay. Yes. Because Little Crow just told you. And I learned a lot by making mistakes, and I made this particular mistake quite a bit myself. And I would argue, why do we have to do this? It just is. That it's implied, right? There's a lot of things in this world that are just sort of implied, and you say, well, it's not in the law, it's not written that way. Yeah, maybe it's not written, you have to stop at the stop sign. Rolling through, I sort of stopped enough, but if the police stopped you, they said, well, it was a rolling stop, not a complete stop. So, well, where's that written? It's probably written somewhere, but there's a lot of things in this world that are implied, and in algebra, variables are implied to have this nice tight protective suit around them. So if you start off putting it, it'll get you correct answers, and then you'll see how things work, and you might not need to do it anymore. You can get a little bit sloppy. Yes?
So is it because the 2 is up there that's what makes it
Yes.
have to be in the parentheses?
Well,
Or is it just, it always is like that?
always. So if I have
Okay.
2, well, let's see. If I gave you 2x plus 3, this also is implying that there's a nice tight parentheses here. Now, a lot of times when we plug in, it doesn't cause us this problem. Squares are the things that cause a problem because because it'll do it before it's supposed to do it, right? It's really supposed to put the negative on and then square it, but because of the way it works, okay? Over here, it won't cause us any problems if we don't put the parentheses. We just put -2, -2 times 2 is -4. We'll probably be okay. But it's just here, the calculator will even tell us, and I've had students argue with me, but the calculator says this is right. I says, yes, it's doing exactly what you're telling it to do. The part that's wrong is that this needs to be set up like this, not like this. And you're right, there's no rule book that said that. Probably no other teachers told you that. They just assumed that you got to do it. And again, a lot of times, maybe in 70% of the problems, it doesn't matter, so you get by without it. But in the ones that it does matter, it's a big deal.
So how then will you know if it matters or it doesn't matter?
Just do it all the time.
Oh.
Just do it all the time. If you get used, and this is what I found is when I was struggling with math, which is like yesterday, okay, I got a 3-color pens, one of those red, green, and I would colorize things. So I would write this, and then I'd put parentheses like this. I said, there's a parentheses around. I'd do it all the time. And you're going to see, I just did this with my Math 121, taking this out, it's a place where we're going to plug in. If we do this, it's going to make everything else so much better because everything will be correct. When we put in our calculator, it will agree with what we're doing. And we won't make the mistakes. And just keep doing it until you know when you can stop.
So does it always apply to a letter only, or?
It does. Because when we're plugging into a letter, we're plugging right into that letter. It always has a parentheses around it. It's always implied. Nobody ever told us. It wasn't written down in the rule book, but it's always implied. So it is always there. So it's never wrong to put it. It's just we get a little bit lazy sometimes and don't want to do it. And that's okay if we know, if we've internalized how it works, right? But if you always do it, you'll never go wrong. Okay. Everyone else tired? Yeah, there's some problems, few tries, applications. That's a good place to stop. And I'll tell you why. Because, again, this class is mostly skill-based. The applications are always very wordy problems. We'll get to them, but we have the skill part of this down. And I tell you what, when we get to lesson 3, we will be applying a lot of things anyway. So these are your extension problems. These you can skip this if you'd like. You got it. You got my word on it, and you won't be hurt. It won't matter. In fact, I would skip these at first and go back and do the lesson. And then if you want to try a few of these, great. More power to you. It's going to strengthen you. But if you want to skip it too, no harm, no foul. You'll make just great progress, kind of keeping going with the progress and getting the skills built. And again, when we get to lesson 3, we will do plenty enough applications. But by then, we're actually solving problems. These applications, we don't even get to solve them. So it's like we go through this whole story problem and we don't really even get an answer. That's what this one frustrates me. So I like to get an answer. When we get to 3, we will actually be able to solve it and get an answer. So we've got the story, we've got the solution, and we go forward. So in these first 2 sections, the applications are just sort of like extra. Okay? Don't worry about them. Get everything else done. And if you're really bored and have nothing else to do, sure, go ahead, work the application problems. But hopefully you got something better to do. I can think of a lot of things that are better to do than application problems. Thank you. I almost forgot. Yeah, so how can you get attendance if we don't have a word of the day? The word of the day. Who hasn't given us a word of the day yet?
Oh, I got one.
You do?
Miracle. I'm going to need a miracle to get through this, so it seems appropriate enough.
Okay. Word of the day. Miracle. Did I spell that right? It's an E. A? Miracle. Thank you. So that's, we'll have it correctly spelled. Okay. So hang in there. Again, this is the end of the formal part of class. We have until 7:15 at least, and if you got more problems, I'll stay, but we will make sure you're able to work through things, get your questions answered. So thank you, folks. Word of the day, miracle. So if you're watching, there it is. If you're here, there it is. We'll have a quiz. Thanks.